For this problem, we are required to find 2.14 sine 75 correct to 2 decimal places. So, the statement of the problem: find the exact value of 2.14 sine 75 degrees, giving your answer correct to 2 decimal places. 2.14 sine 75 means that 2.14 is multiplied by sine 75. So that is what 2.14 sine 75 means. It means 2.14 should be multiplied by sine 75. We may find sine 75 degrees and multiply by 2.14. Or we may carry out the process in one step. As a matter of fact, the calculator these days will perform the calculation in one step. Therefore, the requirement of the problem might not be just to be able to use your calculator, but also you might be evaluated on your ability to write the answer correct to 2 decimal places, because that is also a requirement of the statement of the problem. So you will multiply 2.14 by sine 75. Your calculator can do that in one step. So the requirement is not harsh because your calculator can perform that particular operation in one step. So 2 decimal places, we are going to be focusing on the 2 decimal places also. So what we do, we take 2.14, we find sine of 75 degrees, then we multiply those together. The 2.14 is multiplied by sine 75 degrees. Because we need 2 decimal places, we may write the value on the calculator including the 3rd place of decimal. Because we need 2 decimal places, we need to write that correct to 2 decimal places. We may go straight ahead and take the numbers that we have there, multiply them together. The result is 2.067, and of course we will have quite a few other decimal places following. But because we are required to write it correct to 2 decimal places, we include the 3rd place of decimal, because while writing the number correct to 2 decimal places, we will also need to consult the 3rd place of decimal. Therefore, we are writing the answer that we get right here, inclusive of the 3rd place of decimal. We are writing correct to 2 places of decimal, so we are going to identify the 2nd place of decimal, which will be the 2nd digit to the right of the decimal point. So there we are identifying the decimal places 1, 2, and of course 2 places to the right of your decimal point. And there we have your 2 places of decimal. Right. So we are going to write that to 2 places of decimal, and we have identified the 2nd decimal place. Now we are going to write it correct to 2 places of decimal. Generally, we might include the rest of the digits after we have settled on the 2nd decimal place. But now we are writing the other digits first. Now we are going to focus on the 2nd place of decimal. Now we will consult the 3rd place of decimal. While writing a number correct to 2 places of decimal, we need to identify the 2nd place of decimal. Then we need to consult the 3rd place of decimal. Why do we need to do that? There we have the 3rd place of decimal. If the digit in the 3rd decimal place is greater than or equal to 5, we will add 1 to the digit in the 2nd decimal place. So we identify the second place of decimal because we are writing this number correct to 2 places of decimal. Then we consult the third place of decimal, because if the digit in the third decimal place is greater than or equal to 5, we will add 1 to the digit in the second decimal place. If not, then we will just leave it alone. If this one is less than 5, this will remain the same. If it is greater than or equal to 5, then we will add 1 to 6. So there we go. Because 7 is greater than or equal to 5, then we will add 1 to 6. And our answer will be 2.07. Now we will take a look at how we will achieve that on our calculator. So there we have our calculator, and we are just going to demonstrate exactly what we need to do. First of all, we have to ensure that the calculator is in degrees, because we have other angular measure that the calculator might be programmed to handle. At the moment, it is programmed to handle degrees. And if we are going to solve that problem, do not forget that we have 2.14 sine 75 degrees. Therefore, your calculator should be in degrees first. So the calculation could have been done in one step using the calculator. Ensure that the calculator is in degrees. The angle whose sine we need to find is in degrees. Do not forget that. So our calculator is in degrees, as we have it right there. We have 2.14. How do we arrive at that 2.14 on the screen? So enter 2.14 by making use of the numeric keypad. So identify the numeric keypad. There we have the numeric keypad. What do we do next? We will put in 2.14. 2.14. We might do that again. 2.14. What do we do next? So 2.14 sine 75. So we need to enter sine. Where do we find the sine? Then press sine as we have it on the screen. Right there. Right there. Press sine. And then we know what will follow. Sine 75. So 75 will be next. We need the sine of 75 degrees. Use the numeric keypad to enter 75. That's what we will do next. We do not need to worry about the symbol for degree, because the calculator right there is already in degrees. So we don't have to worry about the symbol for degree. So 75 degrees, 75. That's all. 75. And of course, what do we do next? In order to have the final answer that we have on the screen, we finally need to press equal. So we need to be able to identify equal on the keypad also. And that is the last thing that we need to enter. The answer displayed will have 10 digits of an infinite decimal number. I choose to write the answer given inclusive of the third decimal fractional place, because the answer required should be rounded to 2 decimal places. So when we got our answer on the previous slide, we chose to just write it 3 decimal places alone. We didn't have to write all of them, although we know that it is an infinite decimal. It will continue indefinitely. We chose to use up to and inclusive of the third place of decimal. Why? Because the answer was required to be in 2 decimal places, and in order to do that, we would have to consult the third place of decimal to see whether or not it is greater than 5. So I hope you enjoyed seeing your calculator on the screen, and I hope that everything is explained in this audiovisual as simply as I intended it to be. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.